So taking a look at Phidgets with Scratch. So this is something that we released a few weeks ago, and this is basically being added on to our kind of Chromebook support. So now for Chromebooks, we have MakeCode, which you can use, and now we have Scratch. So it just kind of broadens that Chromebook experience, that web-based experience, and allows you to do more things with the Phidgets that you have. So the best way to access Scratch with Phidgets is still through the phidgets.com/start. So that's kind of the main link that you give to students when you start out with Phidgets. So if we go to phidgets.com/start, we'll be met with this page here. So now you can access Scratch through this tab here. So that'll bring you to this page. If you're just on the education website in general, you can also link to it from the Scratch button in the top corner here. So I can click on that, and that will bring me to the Phidgets with Scratch page. So this is what we recently released. So all you're doing is you're kind of following these instructions right here. And then what we've done is we've created some starter projects. So basically all the sensors that work with Scratch will have some starter projects to get you going. And they have some content and some questions like you're used to with Phidgets. And then we just have some FAQs at the bottom, but pretty straightforward. The idea is more to kind of augment Scratch so that your students can do more with it. So if you're already using Scratch, they can add some sensors like a thumbstick, for example, and make their game that much better. And then once they're kind of comfortable with Scratch, they can go on to MakeCode, they can go on to Java, Python, whatever. So it's just a nice little extension for Phidgets. So anyways, so the first thing that you'll do if you want to use Scratch is there's a few buttons to open the editor. So there's this button up here that says click here, and that'll bring you to the Scratch editor. And you can also click this one down here. But the link is phidgets.com/scratch. So that will bring you to the Scratch editor, which we're seeing right here. So there's a few things to do once you get to this page. The first thing to do is make sure that your device is actually connected. So what I'll do is I'll just disconnect my device, my hub, and then I'll reload the page here. So when you get to this page, if you're doing it right now on your computer, you'll probably see that this button says Connect Device. So there's a button right up here that says Connect Device. So that's the first thing that you're going to want to do. So once they have their getting started kit, whichever one it is, or just if they just have a hub and they have some sensors. So they have this, they want to plug into their computer. So I'll plug into my computer here. And then the first thing they'll do is press Connect Device. So Connect Device like that. And then you'll get this pop-up window here that says Phidgets.com wants to connect. So just make sure that you're selecting the hub and then you're pressing Connect. So that's the first step there. And then the next step is to click on the Add Extension button. So in the bottom left corner, there's this Add Extension button. So you're going to want to click on that, and that will bring up all the different Scratch extensions that you can use with the Phidgets Scratch library. So here we want to use Phidgets Education. So click on that, and that will give you all the Phidgets blocks. So again, there's basically two steps. You go to the URL for the Scratch editor, you connect your device, and then you add the Phidgets extension. So after you do that, you have access to all the Phidget blocks, and those will give you access to a handful of the sensors. So what we've supported in terms of sensors, it's listed on the slides here. So basically anything that comes in this bundle is supported. To start, you have thumbsticks. So this is a really nice sensor for Scratch, because obviously you can have the user input of the thumbstick, and then it also has a button. So you might be able to hear that, but it has kind of like the axes, and then it has a button. So it's really nice for adding functionality to a Scratch game. The other one is a slider. So the slider comes in the new bundle. The new slider looks a little bit different than this, but same functionality. So it allows you to have user input by sliding this knob here, which is really nice. We have support for the Sonar Phidget. So the Sonar Phidget is going to be in the new bundle. And this is the distance sensor that allows you to measure distance. So there's a lot of cool use cases with that, and we'll show you that in a minute. We have the light sensor, the accelerometer, and the humidity Phidget, and then of course the getting started kit itself. So buttons, LEDs, those are all supported under Scratch. And then basically you can also just see, so you can go through once you've added those Phidget blocks. You can go through and just scroll through them and look. So there's the getting started kit category. There's an input category. So input is thumbstick and slider. And then there's a sensor category. So accelerometer, distance, light, temperature. And there's an advanced category, so maybe we'll touch on that later today. But primarily you'll be using these ones up here. So getting started kit, input, and sensors. And then from there, it's very simple. So all you have to do is once you're connected, you can drag on the block you want to use. Maybe I'll increase the size of this a little bit, but so I can drag on an event block here. There we go. Yeah. So hopefully is that okay? There we go. Yeah. So I can drag on an event block here. So this one is saying when the red button's pressed, that's an event. So I could do something like I could move my sprite, or let's turn our sprite 15 degrees. So basically I've added that code to my editor basically. And now if I press the red button, we can see that the sprite is now moving. So really, really simple, but actually quite fun. We did a bunch of testing with this in classrooms, and students have a blast when they're starting to add the physical elements to their Scratch projects. So pretty interesting use case for Phidgets, and pretty fun. And you can actually do some pretty complicated things. It's like pretty sophisticated projects, which is quite nice. So taking a look at the projects that are available. So if we go back to this this page here, that Phidgets with Scratch page, as I mentioned, there are starter projects available. So there's basically every sensor that's supported will have a starter project. So the first one we'll take a look at is this move and jump with the Getting Started Kit one. So I'll click on this, and this will bring us to this page here. So these are all laid out in the same way as the other projects on education. So very similar. You need the Getting Started Kit for this one. So you can use the old Getting Started Kit or the new one, it doesn't matter. And then basically what they have is they have code. So when they're doing the project, the idea that they copy this code into their editor, and then at the end of it, there's some practice problems that they can do. So you can also download the project here, which I'm going to take advantage of today. So I've pre-downloaded everything. And then what you can actually do on Scratch is you can go to File and press Load from your computer. So File, Load from your computer. And then I have the project here, Move and Jump. And then I can load a project. So they can load something they've been working on previously. They can save it at the end of class and then load it the next class to keep working on it. But essentially, this is that program that we're seeing right here. And what we'll do, I'll run it. So this one is based off of a green flag event. So you probably, I think before you start using Phidgets with Scratch, you should probably be a little bit familiar with Scratch. So if I do my green flag event, my code will start working. And then essentially what this project is it's very similar to what we just saw. So they use the red button and it's moving their sprite. So every time I press the red button, it's changing the costume and moving the sprite. And then when I press the green button, it's jumping the sprite there. So I can move, I can jump, and then it's also kind of looping the sprite through. So they can take a look at their code here. There's a forever loop. There is the if statements for the buttons. So instead of using button events, there's an if statement here for red button pressed and green button pressed. And then at the end, they can check their position. And if it's at the edge of the screen, so if their position is all the way over here, it re-loops it back to the other one. So just a very basic getting started project, but pretty interesting, pretty fun. And then I've seen students expand on this. So they've made side scrolling games. So instead of the head of the sprite looping back, once it reaches the edge of the game, they load a new level, and then they add obstacles. They add all these different functionality pieces, which is really quite nice. So again, those are actually also talked about here. So, practice problems as usual. So you can have the students go through the projects, you can assess them on the practice problems, or you could just use this as a little bit of a template to get them going. So that's that first one there that just uses the Getting Started Kit. The next one that we have is a Accelerometer project. So this one actually uses the accelerometer to move a sprite. So again, we have all the same setup that you'd be used to in our other projects. So for this one, they're using an accelerometer Phidget and a hub. What you can do, you can always have the hub separate from the Getting Started Kit. So you can take it off and use it separately. Especially with the new one, it's easy to just add sensors on. So for example, I'll take a sensor cable, I'll add it onto my hub. So I've just added it to port 3, and then I'll plug in a accelerometer. So you can use it like this, just attach to your Vint hub or attach to your Getting Started Kit, or you could have the Vint hub separately. It doesn't really matter. The nice thing about having it on your Getting Started Kit is that you can take advantage of the buttons and LEDs. So if you want to use the accelerometer and the buttons. It just kind of makes it a little bit nicer. But here I've added my accelerometer. So what I'll do is again, there's code down here, but I've already downloaded that, so I'll just load it up again. So this one is flying, and then it'll ask me to reload. So yep, so there we go. So here I have an accelerometer project. So I'm getting a warning here saying that the accelerometer did not attach. And the reason for that is that my port that I plugged my accelerometer into is port 3. So I'm just going to make sure that I modify that to port 3, like that. And then I press run, and now it's running through the code. And essentially with this one, the idea is that if you're tilting your accelerometer, so if I tilt it this way, the bird flies that way, and if I tilt it the other way, it flies up. So just showing them how they can use the tilting functionality of the accelerometer. And of course, there's a huge number of projects they can do with this. This is just showing them some of the basic functionality. So there it keeps spinning because I have it tilted there. So that's the accelerometer has a few different options in terms of what you can actually use it with. So if we just pull out this block here, maybe I'll get rid of this, and then I'll just enlarge this a little bit. So you have a shaken event, you have tilt up, left, down, and right. So basically, if they shake the accelerometer, so they can shake this to cause events, or they can just do the tilting events. So that's the flying project there. We'll go back here to the Scratch projects. The thumbstick one is probably one of the more favorite sensors to use with Scratch, just because it's obviously a natural kind of input for games. So I'll disconnect my accelerometer, and I'll plug in my thumbstick here. And then again, the code is provided down here. So what I'll do is I'll go back in here and I'll just load it up again. So this one is movement. So in this situation, what we've done is we've shown them the basics of how to actually move a sprite with the thumbstick. So again, just make sure that you're setting your hub ports correctly. So again, mine is on port 3. So I'll just have to make sure that I change all these to port 3 so that it actually works properly. And then I have another event here. So this is the thumbstick pressed event. So I mentioned that the thumbstick has the movement options. So you can move the thumbstick, and then you can also press down, and that will have an event there, which we just saw here. So essentially, by moving the thumbstick, let me just run the code here. So running the code, we'll run the main loop. So by moving the thumbstick, I can now move my sprite all around the screen, which is pretty fun. And then by pressing on it, I can change. In this situation, I'm changing the costume of the sprite. So here I'm changing it from different types of fish, essentially. But this is obviously a pretty big favorite with students. So they can kind of add that nice functionality, that nice scrolling effect. If they have a side scrolling game, they can use this, and it just makes it a little bit nicer, a cleaner way to input as opposed to the keyboard. So that's a thumbstick project there. And again, all of the code is shown here, and it's all fairly straightforward. They start with forever loops, and then they're just checking. So the thumbstick has events. I'll just show you that quickly. So the thumbstick has pressed events. Maybe I'll just get rid of all this code here to show you. There you go. So the thumbstick has pressed events, as we can see there. So that's for pressing the button. And then it also has these statements here. So you can do if it's up, if it's down, if it's left, and if it's right. So it just makes it a little bit easier to create their project. And then again, they have that starter code they can use. And then of course they have practice problems here. So pretty fun stuff there. What else do we have? So the Pong one. So this one is a Pong game. And what they do with this one is they're using the slider. So this slider is quite nice. It's for these types of games like Pong and anything where they want to move something along either the vertical or horizontal axis of Scratch. So again, we'll upload this project just to give you a look at it. So this one is Pong. And essentially the idea with this one, the slider is pretty easy to use. So they have this option here to use horizontal or vertical, or they can use 0 to 100. So I'll show you what that looks like in a second here. But for now, I'll put this on port 3. And then I'll run the code here. So essentially port 3, and now I have my slider. And basically this is mapped to the horizontal limits of the screen. So basically, we've saved the students from doing kind of too much math here. It's a little bit of a math problem to map it. So they can do horizontal, and it will basically give them the full stretch of that screen. I can show you what that actually means if I use. I think there's a say thing. Yes. Let's see if we go like this. So if we just output, let's just do this actually. If we output what the coordinates actually are, so we can actually see in that, I'll make that larger so you can see that. So when they're moving from left to right, oh, you can actually see it up here too. There's the output there. Oh, I see. Let me just put this in a forever loop. There we go. So you can see the output of that slider. So it's from 240 to negative 240 for the horizontal. And then if they do the vertical, it's from 180 to negative 180. So it gives you the output there, and they can also use it. Some students were using this for volume, I believe. So we give them a 0 to 100 output. So if you slide it from 0 to 100, it'll do that as well. So we give them a few different options for the output of the slider just to make things easier. And then the point of this one is they have practice problems here with a little bit more code, and they actually add the ball. So they add a ball sprite and they add a little bit more code, and then they will have that actual Pong effect at the end of it. But the idea with these are just getting them comfortable with each sensor and how it works, and then they can actually use them in totally different ways. So that's generally what we see is a student will start with, they'll start with the thumbstick in that one we showed you, and then they'll have their own idea for how they actually want to implement this, which is quite fun. So that is the slider one. And then the last one I'll talk about today is the distance sensor. So the distance sensor, this one actually shows a different one, but essentially any fidget that has a distance sensing element you can use. So in this situation, we're using it for audio. And actually, maybe I can share make sure my audio is shared. Share sound, there we go. So if I load up that project, what we do with this one is we create a theremin. So I'll unplug my slider, and I'll plug in my distance sensor here, like that. And essentially with this one, the code lives in the saxophone sprite. So depending on when you have multiple sprites, sometimes the code is in a specific sprite or is tied to a specific sprite. But essentially this one is using the distance of that the sensor is measuring to change the pitch of the sound. So if I play this, you may be able to hear that. I'm not sure if you are able to hear that, but as I go closer, you see the pitch changes. Maybe, I'm not sure if you guys are able to hear that or not, but if not, you could try this one. If you have a getting started kit, you could try it with buttons just to create that pitch effect, and it's pretty cool. So lots of different things they can do with the distance as well. Okay, awesome, you guys can hear that. People also did Pong with the distance. They were using that to move their paddle. There's a lot of different options they can use. That's just one little option there. So that's all the projects that we have. So the idea again is just to get them started, get them kind of understanding how they can use a sensor, and then what they generally do is use it in whatever way they want to. We find that students get really, really creative with Scratch. And they generally have an idea of what they already want to do, like they have their games or they have the project they're working with, and they kind of just use these to make them even better. So pretty cool stuff there. Again, the main points with Scratch are that you want to make sure that you have your sensor connected. That's a big kind of pitfall. And the other pitfall, or the other thing to consider, is that so this is not tied to the official Scratch page yet. We're going to hopefully in the future be getting on as a Scratch official extension. So you will be able to log on to your accounts like you would if you went to scratch.org. So that's one thing to note too. So you won't be able to use, you won't be able to pull in your Scratch projects using the cloud-based projects, but you can download projects and re-upload them here. So that's what we had a lot of students do, was if they had a project on Scratch. So we had one student who had a really multi-level game. He downloaded that project and then uploaded it to this this instance of Scratch here, and he was able to modify it with Phidgets. So that's one thing to consider. And then the other thing is just, making sure your device is connected and making sure that you actually have added the blocks. And then from there, it's actually just quite a fun, it's a nice add-on to the web-based Phidgets. So now you can use Scratch and you can use MakeCode, and there's going to be more in the future. So it's a nice add-on there. But that's all I have for the Scratch webinar today. If you do have any questions about it, feel free to stick around and let me know. If not, we do appreciate you stopping by, and we hope that this was useful and that you learned something from it. Yeah, let me know if you have any questions. Thank you.